Development planners determine the number of new housing units needed in a certain area by using the formula H is equal to K times J, where H is the number of new housing units needed in the area, J is the number of new jobs to be created in this area, and K is a constant. So that makes some sense. If you need more jobs in some area, you should need new housing, which is reflected by this equation. How many new housing units did the planners determine were needed? So if we want our new housing, we need our K, our constant, as well as our J, our number of new jobs expected to be added. And they don't give us any numbers, so let's look at our statements. The number of new jobs to be created was 60,000. So this is saying H is equal to K times 60,000. I still need to know K though, so insufficient. Statement 2. According to the formula used by the planners, if 37,500 jobs were to be created, so that's J, then 7,500 new housing units would be needed. So we're looking for H, the actual H. They're saying H would be 7,500 in this hypothetical situation. So 7,500 is equal to our constant times 37,500. So what can we do here? Here we can solve for K, right? And once we have that K, since K is a constant, we can use that K in any situation. So like that K does not change ever. And so we can really just plug that K right into here, into our generic formula. And so K is equal to 7,500 to 37,500, which is 75 over 375, which is the 150 times, so we get 375 should be divisible by 75. It's 75 times 5, so 1 over 5. So K is 1/5. Okay, now so based on statement 2, I know my actual H is going to be equal to 1/5 times J. So I need to know the actual number of jobs to be created, not this hypothetical number they gave us. So I still need J. And where can I get that from? It looks like statement 1 gives me J. So statement 2 is insufficient. But combined with statement 1, I know H should be equal to 1/5 my constant times 60,000, which means 12,000 housing units would be needed. So C.